solution architect at Anaplan. I want to take you through a build that I did recently using Anaplan's optimizer to solve a pressing but personal issue. I'm going on a golf trip, and there's going to be 8 of us playing across 3 days. And I wanted to make sure that every player got to play with every other player at least once, and preferably not all 3 days. So let's take a quick look. I'll start with the end where we ended up, the page that a user could use, then an app called Golf Group Planning, and this is strictly for foursomes. So I've got a list of 12 golfers, with one being an open spot. So this particular model will work for 7, 8, 11, or 12 golfers, and it'll work for 3 or 4 days. Actually, it would work for 2 days as well. You could obviously make it larger and able to handle more golfers or more days, but that started to make it more complicated, and I wanted to keep it straightforward. So in this case, I've chosen the 8 golfers that are going to be playing across 3 days. I'll run 2 actions. One is to load these choices into the list in the model. And then the next one is to actually run the optimizer. You'll notice that it runs very quick because there's not a lot of data, not a terrible lot of constraints. So it runs quickly. So to look at our results, first result is the actual assignments of groups. So you'll see that each day there's 2 foursomes. And in each day, you'll see the 4 golfers that are flagged that'll be in that group together. You'll see this later, but some of the constraints are that each golfer is assigned to one group in each day. So everybody gets to play all 3 days, and that each foursome has exactly 4 players in it, which is a requirement. Then we scroll down. And we scroll down to the final part of the page where we see the pairings for the week. This confirms that everyone plays with everyone at least once. That's all the ones that you see. There was, we couldn't meet all our criteria. So it is unsolvable to not play with somebody else all 3 days. So you see the line going across where each person, so we have the golfers on the left, and then another list, which is partners across the top. This is one of the things that makes this problem challenging, is that each time you put me with Randy, say, then you're also by default making Randy play with me. So keeping that relationship constant and maintained is a little bit of a challenge that we'll look at in just a minute. So this is partners and golfers. You see all of them are matched up once. This line going diagonally is just showing that each person is obviously playing with themselves each day. And then each person has one other person that they will play with all 3 days. And if you took just a few minutes with a pen and paper, you could prove to yourself that it's impossible to not have that be the case and still meet the playing with everybody once criteria. Let's take a look at the model. In the model, we've got a number of modules, mostly system modules that I won't particularly go into, a couple of input models, and then the 3 that I will look at are these 3 that are at the end for variables, constraints, and an objective. First, let's look at the most important lists. We've got a list of the golfers. This is a subset that we populated from the page. Got a replica of that we call partners, the same names, and updates the same subset. And then we have a foursome, or the groups, where we're updating how many days we're playing, so that we get only the subset gets updated for just the days we're playing. It also counts and knows how many people are playing, so it knows whether to populate 2 groups or 3 groups, or it could do 1 group. So that's some of the setup. Now for the optimizer, that's an action. So if you went in under new action, you'll see optimizer. So I've already created that. We'll dive into that and take a look. You have a choice on how long it will run. In bigger problems, that could be very much a concern. In this case, we want to do the linear programming. We've already proven that it's feasible. We want a specific solution. This is a little bit interesting that we'll talk about in a minute when we look at the objective module, but we're going to minimize cost. We've assigned a cost and we're going to minimize that in order to allow optimizer to drive to a solution. We've got 3 variables, and we'll look at those. These are all independent of each other. And then we'll have constraints that help keep these tied together. And in this particular case, we have 7 constraints, which we'll look at in the constraints module in just a moment. So this is what runs. So let's take a look at the modules. Under our objective, it's very straightforward. We're taking one of the variables, first variable, and we're just giving it an arbitrary value of 100. And then this is what we're minimizing. So there are multiple solutions that would work. This is just a way to make the optimizer run. So we're not really expecting, it might not make sense to you off the top that we minimize a cost, but this forces the optimizer to come to a solution, which is all I was looking for in this particular case. You could extend this by using handicaps and trying to drive each group to be either equal in handicap or minimize a delta between the teams. Lots of options that you could do to extend the abilities of this module. Take a look at the variables. We have the 3 variables. And one of the things you'll notice in both the variables and then in a moment in the constraints is that we vary a little from best practice by not having a separate module for each set of dimensions. So in this case, we have 3 different sets of dimensions for the 3 different variables. This allows us to keep them all in the same module, and it's much easier to keep track of them within Optimizer this way. We'll take a look at those. It's actually easier to look at it in the subsidiary view. So these are the partner list. So the partners have to be assigned with the groups. So 4 to each group, 1 in each day. The golfer will look exactly the same. It's a different list, but it looks the same. It's the ones we've chosen across the days we've chosen, and 1 gets assigned. So this is the part. Variables are what we're letting, when Optimizer runs, it assigns these 0s and 1s. The interesting one is a golfer partner foursome, which is the one we see on the results page. But this is where it matches them up. So let's talk about how that works by looking at constraints. Here again, we've put all the constraints in one module, and we have multiple different dimensions depending on which things we're looking at. So constraints are all Boolean. They have to be Boolean. And so each one we're going to solve for something different. So this one, we want to make sure that every golfer plays every day. And we also have to make sure that each golfer is their own partner. So this is where you'll see down here where we force using a system variable lookup that each golfer is their own partner. This is where we set a max, so you can only be, and this is driven from the input variable on the page to say how many times, which if you'll remember on the page, we set it as how many days playing, but that sets this value of what are the max number of times they'll play together. Then we have a constraint to only face each other, that everybody has to face each other at least once. So even though it may try to assign all the different values, we're going to force it to only consider the ones where it's at least one for each pairing. Then we look at the ones that I referenced on the page. We're going to put 4 players in each group. And then we have the assignment where a golfer is a partner and a partner is a golfer, so that so each pairing works for both the partner and the golfer. We'll go back and take one more look at the actual optimizer setup. You'll notice in the variables that we force these to be 0 or 1. Those are the only ones that make sense. So depending on your issue, you could do it differently. And then we have those constraints that we just looked at. I was disappointed that what I wanted was not a feasible solution by not having to play with the same person all 3 days, but Optimizer did a great job. I highly recommend using Optimizer when a problem fits. It's a great solution. It does have to be linear. I was learning. One of the reasons I did this was learning Optimizer, and it was a couple of things that threw me off were the levels of indirection, is the way the training refers to it. You'll notice in the constraints that everything has to look a very certain way. Constraints all have to be equal or greaters or equal. And the levels of indirection mean it can only, particularly in the objective, let's look at that. So like in this, I've multiplied it by a constant here. It can only be multiplied once if what it's getting multiplied by has to refer to another formula. Then the optimizer can't go 2 steps beyond. So with a little trial and error, you can figure out how to do it. It can potentially even address some things that are nonlinear if you follow a very specific way. I highly recommend if you're internal to Anaplan, we have an optimizer Slack channel that's very useful. If you're a customer or want to be a customer, I recommend you get with your business partner and or support, and we can get you to the right people that can help you. Thanks for listening. Hope you have a great day.